We are going to be looking at two problems from section 2 of chapter 3, and these two problems, I've chosen these two to demonstrate two different techniques for using our graphing utility. In other words, the TI-83 or 84 calculators to approximate solutions for equations. The first of these two problems is number 35. I have the equation written here, 2x squared plus 2x minus 12 equals 0. To do this on our calculator, the first thing we're going to do, of course, is to turn the calculator on. And inside of the y equals menu, we're going to put our equation. So we're going to have our 2x squared plus 2x minus 12. So we put the function into the calculator, and now let's graph it. I am going to choose a window that I like. I have stored this window in memory, and here we go. Here's the window that we're looking at. Let me show you this window in case you want to use the exact same one I have. Not the one I thought. Anyway, this is the standard window, and we'll just continue using that for now. So let's look at this graph. If we want to find the solution, since we have that this is equal to 0, the solutions for this are going to be the same thing as the zeros to the function. They will be the same thing as the x-intercepts. And so we can go into the calc menu. The calc menu is the yellow one right above trace. So we'll hit second, calc, and scroll down to 0. We can hit enter, and then it asks for bounds, because if you're looking for a solution, you need to know where you're looking. So let's go to the left one over here. Let's try to find that one. So I'm going to scroll to the left, and I want to get my cursor, there it is, get my cursor to the left of that intercept. I'll hit enter. Then it asks for a right bound, so I'll go to the right of it. I can hit enter. Then it asks for a guess, so we'll just get close, and we'll hit enter yet again. And our calculator tells us that one of our answers is -3. If we want to find the other one in like manner, we can do second, calc, scroll down to 0, or just press 2. And this time we're going to scroll. It asks for a left bound. So I need to get over here somewhere to the left of it. That's good enough. Going a little bit further to the right of it. That's good. And we can come a little closer now. Hit enter. And we get our second solution for this equation. I can write these solutions down if I get my pointer going here. And so, writing these two solutions, we have for this particular one that our solutions are going to be, the x is going to be equal to either -3 or, I don't want to do that, or it's going to be equal to +2. Now let's do the second equation. On the second equation, I'm going to demonstrate a different technique. So first of all, we're going to get into the y equals menu. Let's clear out what's there. And since what's here, instead of doing the algebra and setting this equal to 0, I'm going to enter two separate equations. One of them is going to be 4x plus 2. So let's put that in here. So we're going to have 4x plus 2. That'll be one equation. The other equation on the other side of the equal sign, we're going to have 6x squared plus 3x. Now I'm going to graph both of these equations on the same, on the axes here. And there's the first one. Here's the second one. That's kind of hard to see, so what I'm going to do is I'm going to take a moment and I'm going to zoom in. So I'm going to hit zoom. I'm going to scroll down to zoom in and hit enter, and it asks you where you want to zoom in from, so that's close enough. I'm just zooming in right at the origin. And here's the first one. Here's the second one. I zoomed a little bit too much. Okay. Let me check what my factors are here. So if I go zoom, format. No, that's not what I want. I have zoom. Let me go to memory. I'm going to scroll down to factors here, see what they are. I'm going to change these to 2 because I don't like to zoom that quickly. Okay? So we'll hit enter there. We can quit this now. Now I'm going to go back to the graph, and I'm going to zoom out this time because I'm missing that 1. And so if I zoom out, again at the origin. Now this looks pretty good. Okay, I think I've got them both now. Now the technique that I want to show this time is, again, we're going to go into the calc menu here. So I do second calc. So I do second calc. But this time I'm going to use the intersect method. So I'm using number 5, intersect. Since you could have more than one curve on the calculator, you have to tell the calculator more than 2. You have to tell them which 2 you're looking at. Since they only have 2, I can just hit enter, and then the second curve is the same. Now what you want to do is you want to get your first guess. You want to get that close, and that's pretty good. And so it's going to tell me that they intersect at this point right here. Now for this here, we're not interested in the y value, we're interested in the x value, because that's the x value that makes both of these equations, both the left side and the right side of our original equation, equal to 0. So one of our solutions for this is going to be x is equal to, and we'll use a negative 0.5 or a negative 1/2. The other solution, let's find it. So going back to here, we're going to hit second calc. We're going to choose number 5 for intersect. And once again, we have our 2 curves. And so since I only have 2 in here, this is a no-brainer. We just hit enter, enter. But now I need to scroll close to the other intersect point. So I'm scrolling closer to it, and that looks pretty close. So I'll hit enter. And this time we have an answer of 0.666666, right? So if I take that answer of 0.6666, etc., right? In other words, these are the same thing as negative 1/2 if we want to write it as a rational number, and this one is going to be the same thing as 2/3. So these are the 2 solutions, and this completes these 2 exercises.